In the last class, we looked at coordinate geometry. Today, let us look at the distance formula, where we try to look at the distance between 2 points on the plane formed by the x-axis and y-axis. Let's take a point A on the x-axis. The coordinates of this point would be 4, 0. Let's take another point, this time on the y-axis. Now point B has the coordinates 0, 3. Now let us try to find out the length of this segment AB. As you can see, x and y axis are perpendicular to each other. Let us call the origin as O, which is the intersection of the x and y axis. Now triangle OAB is a right angled triangle. We can see from the figure that segment OA is equal to 4 units. Note that the x coordinate of point A is also 4. Also, the segment OB measures 3 units, as can be seen in the figure. You may note y coordinate of the point B is also 3. Now we can easily find out AB using the Pythagoras theorem. So AB square would be equal to OA square plus OB square. Substituting the values for OA and OB, we find out that AB is equal to 5 units. Now let us shift this segment AB somewhere in the first quadrant. Now the length of this segment is not so obvious, although we know that it measures 5 units. Now let us draw perpendicular lines from these points onto the x and y axis. Now if I were to draw a right angled triangle EAB, we can see that EA is equal to CD, which is equal to 4 units. Also, when we draw perpendiculars from B and E onto the y-axis, we see that segment BE is equal to GF, which is equal to 3 units. Now once again, we can apply the Pythagoras theorem on triangle BEA and find out that AB measures 5 units. Now let us call the coordinates of point A as x1, y1 and coordinates of point B as x2, y2. Now we have noted that the perpendiculars that we drop from these points onto the x-axis and y-axis indicate the intercepts on these axes. The segment CD would measure x1 minus x2 units. Similarly, the segment GF would measure y2 minus y1 units. So how much would AB measure? We can use the Pythagoras theorem in the right angled triangle BEA. So AB would be equal to square root of EA square plus BE square. Instead of EA, we could write CD, and instead of BE, we could write GF. So we get AB equals square root of x1 minus x2 whole square plus y2 minus y1 whole square. Instead of x1 minus x2 whole square, we could write x2 minus x1 whole square. So if we know the coordinates of point A and B, we can easily find the length of the segment AB. This is known as the distance formula. Let us look at a problem. Are minus 4, minus 2, minus 1, 1 and 3, 1 are these 3 points collinear? Let us draw the x and y axes and try to plot these points. Now if I draw a line that passes through points A and B, I can see that the line does not pass through the point C. Alright, if I did not have a graph paper or if my diagram was not drawn to scale, I could make a mistake with these points. Now let us try to find out the same problem using distance formula. Now for these 3 points to be collinear, the sum of 2 segments would have to be equal to the third segment. For example, AB plus BC could be equal to AC, or the sum of the 2 shorter sides out of these 3 would be equal to the third side. Why would that be? Recall that if AB plus BC was greater than AC, then ABC would form a triangle. Let us look at this intuitively. If I were to walk from point A to C in a straight line, or if I were to walk from point A to C via the point B, the latter would be a longer route. Now let us move point B closer to AC. You can see that the triangle is flattening. till B comes to lie on the segment AC. Now you can see that AB plus BC would be equal to AC and they would form a straight line. Now let us extend the same logic onto these 3 points to be collinear. Let us call the coordinates of point A as x1, y1, the coordinates of point B as x2, y2, and coordinates of point C as x3, y3. And let us apply the distance formula for segment AB. Let us substitute the values. And we get AB equals 3 times root 2 units. Similarly, let us find BC. We get BC as 4 units. Now let us apply the same formula for the segment AC. We get AC as square root of 58 units. Now AB and AC look quite complicated. Let us simplify. So instead of square root of 2, we put 1.414 and we get AB equals 4.2 units. To find out the square root of 58, you could either use a scientific calculator or use the long division method. Let us see how to use the long division method quickly. Let us form pairs out of the digits of this number. Now 58 forms a pair. Now which square can be subtracted from 58? The largest square would be 7 times 7 equals 49. Upon subtraction, I get 9 as the remainder. Now let us put a decimal after 58 and a pair of zeros. Let us copy this pair of zeros after 9. So we get 900. Now look at the quotient. 7. Double it and write it as the divisor. So we get 14. Now what digit should I put after 14 and multiply it with to get a number less than 900? Let us try 6. So 146 times 6 gives me 876, a number less than 900. Upon subtraction, we get 24 as the remainder. Let us put another pair of zeros after the decimal and copy that after 24. So we get 2400. Now look at the quotient again without the decimal. So 76 times 2 gives me 152. Now I have to put a number after 152 and multiply it with the same number to get something less than 2400. Let us try 1. So we get 1521 times 1 as 1521. So my square root of 58 comes out as 7.61. Let us round that up to the first place of decimal. So I get AC equals 7.6 units. Now let us select two sides which are shorter out of these three and add them. So AB plus BC gives me 4.2 plus 4, which is 8.2 units. Clearly, this is not equal to AC. Hence, the points are not collinear. Let us look at another problem. Find the point on x-axis which is equidistant from 3, -1 and 0, -4. Let us draw a diagram again. So point A we shall plot by taking 3 on the x-axis and -1 on the y-axis. So we get A 3, -1 in the fourth quadrant. The other point 0, -4, the x-coordinate is 0. So we shall have to move on the y-axis. The y-coordinate is -4. So B, which is 0, -4, would lie on the negative y-axis. Now let us see if we can find a point equidistant from A and B. Let us try to move on the x-axis. It seems like point C, which is -1, 0, could be equidistant from A and B. Again, my diagram may not be to scale. Let us try to solve this problem using distance formula again. Now we have to find a point P on the x-axis. So the coordinates of point P would be x, 0. Let us call the other 2 points as point A and point B. Now, since this point is equidistant, AP would be equal to BP. Once again, let us name the coordinates of point P as x1, y1, the coordinates of point A as x2, y2, and the coordinates of point B as x3, y3. Now let us substitute the distance formula for both these segments. Let us square both the sides and let us substitute the values. Now let us expand the brackets using algebraic identities. Here 3 minus x whole square can be expanded using a minus b whole square or a square minus 2ab plus b square. Let us simplify and solve the equation. We get x is equal to minus 1. So point P would be minus 1, 0. Let us look at another problem. A point x, y is equidistant from 3, 6 and minus 3, 4. Find 3 such points. Let us call the unknown point as P with coordinates x, y, point A 3, 6 and point B minus 3, 4. Now once again, we are given that AP is equal to BP since point xy is equidistant from A and B. Now let us substitute the formula, squaring both sides and putting the values. Upon simplification, we get an equation in two variables, 3x plus y equals 5 or y equals 5 minus 3x. Now recall that we had to find 3 such points. Let us assume a value for x. If x was 0, I would get y equals 5 from this equation. So 0, 5 would be one such point equidistant from A and B. Let us put x equals 1. Upon substituting the value of x, we would get y equals 2. So 1, 2 would be another point. You could put any value of x. Let us put x equals minus 1. We get y equals 8 from the equation. So minus 1, 8 is the third point equidistant from A and B.